Chemistry, Mrs. KJ here, going over lesson 1.20, Scientific Method and Chemistry. The scientific method has been used for centuries to answer questions about the natural world. How long does it take liquids to cool? And what factors affect the rate of cooling? In this lesson, you will learn the steps involved in the scientific method and how those steps are used to solve problems such as these. Goals for this lesson: list the steps in the scientific method, give a scenario, and describe the use of the steps in a scientific method in solving a problem. First, you question. Then you observe and explore. Then you hypothesize and make predictions. Do an experiment. You analyze the data. If the data does not agree with your hypothesis, you reconsider your hypothesis. If the data does agree with the hypothesis, you form conclusions. You get your study guide. Observations lead to questions and the scientific method. So scientific investigations begin with a question. Kyle is studying chemistry with his classmate Brianna. They meet in a local coffee shop to discuss ideas for the upcoming science school fair. Kyle orders several cups of coffee and he drinks his coffee with cream. Sometimes when the server brings his coffee and cream, Kyle adds the cream right away. At other times, he gets distracted by his discussions with Brianna and does not add the cream immediately. After several cups, he notices that sometimes the coffee has cooled faster than at other times. Kyle wonders whether the time at which he adds the cream makes a difference in how fast the coffee cools. He mentions the observation to Brianna and asks if she thinks it might be a good project for the science fair. Brianna suggests that they should use the scientific method to answer Kyle's question. The scientific method is a process for answering questions and solving problems. The modern scientific method has developed over many centuries through the work of many scientists worldwide. The steps of the scientific method include the following. Number 1, ask a question or identify or define a problem. Number 2, make a hypothesis. Number 3, test the hypothesis by performing experiments or making observations. Number 4, organize and analyze data. Number 5, draw conclusions. Number 6, communicate the results. The scientific method relies on inductive reasoning to solve problems. In inductive reasoning, you study many conditions or experimental trials and draw your general conclusion from them. Inductive reasoning starts with observation. So inductive reasoning, you may have heard of deductive reasoning, which is a different type. So inductive reasoning is a type of reasoning that is based on observations of patterns and past events. A hypothesis comes from a question. Ask a question and make a hypothesis. Kyle asks, does the time at which I add the cream make a difference in how fast the coffee cools? Now Kyle must refine his question into a hypothesis, an educated guess, statement, or proposed explanation about an observation. A hypothesis must be a statement that can be tested. Often hypotheses are formulated in the form of if-then statements. For example, if I add the cream immediately, then the coffee will cool faster than it does if I add the cream later. Or, if I add the cream immediately, then the coffee will cool slower than it does if I add the cream later. Both of these statements can lead to a test and also suggest that test might occur. It doesn't matter if he's right or wrong. What matters is that his hypothesis can be tested, and he's only testing one thing at a time. So let's look at our notes. I left the beginning in, and we have a hypothesis. It's an educated guess about the future outcome of an experiment or observation. It may be framed as a detailed question or statement, like an if, then, because statement. So if, what you did, then, what you think will happen, because, why you think it will happen. Now, they didn't add the because, but I like to add it because I found that sometimes people hypothesize correctly, but they had the wrong reason, and that's just as important. So if, what you do, then what will happen, because why you think it will happen. Inductive reasoning is a type of reasoning that is based on observations of patterns and past events. Use the hypothesis to devise an experiment. How might Kyle and Brianna test one of the hypotheses? For discussion purposes, use the first hypothesis. If I add the cream immediately, then the coffee will cool faster than it does if I add the cream later. Kyle wants to control the time at which he adds the cream. This is the independent variable, the one that I do, the one that Kyle will change. Which variable does Kyle want to measure? Kyle and Brianna want to measure the temperature of the coffee as it cools. This is a dependent variable because the temperature depends on what time they add it. So the dependent variable because it depends on the independent variable. Dependent variables are usually what the experimenter measures. The hypothesis helps isolate the variable you want to test, so you know exactly what you're testing and you're only testing one thing. Be sure to control other variables. Are there other variables that Kyle and Brianna must consider? Perhaps variables that might change the results. Here are some examples. The volume of the coffee in the cup. Does 200 milliliters of coffee cool differently than 100 milliliters of coffee? The temperature of the cream. Does 4 degrees Celsius cream cool the coffee faster than 20 degrees Celsius cream? The volume of cream added to the coffee. Will 30 milliliters of cream added to a specific volume of coffee change the rate of cooling compared to the 15 mils added to the same volume of coffee? So all those things are what you have to think of, and those are our controls. So these variables, when kept constant, are controls. So, we could list 10 more things they have to keep the same. They need to do it on the same day because you can't do it when it's snowing outside and maybe the coffee shop is 70 degrees, and you can't do it a different day when they have the windows open. It's a really nice day, maybe it's 80 degrees in the coffee shop. So all that kind of stuff. Anything you can think of that can change, you got to keep it all the same except for the one variable you're testing. Controls: an experimental situation or procedure, or a baseline set of data that allows for comparison with experimental results. Other variables. Other possible variables in this scenario include the initial temperature of the coffee, the time when the creamer is added, and the temperature of the surrounding air. Specify and record the experimental procedure. Kyle and Brianna plan their experiment. They will use identical paper coffee cups with 200 milliliters of coffee in each. The initial temperature of the coffee will be 85 degrees Celsius, which is the temperature of most drip coffee makers. They will add 20 mils of creamer at 10-minute intervals. The temperature of the cream will be 20 degrees Celsius. Thermometers will be placed in each cup and the temperature will be recorded every 2 minutes for a total of 1 hour. The experiment will be repeated 3 times. Kyle and Brianna record the materials and the procedure they will follow. This will allow others to reproduce their experiment, which is important. Kyle and Brianna plan the experiment. Now if you're thinking, okay, really, who needs to replicate this experiment exactly? Good point, but think about what scientists really do. They make new plastics. They make the new panels on the outside of your car, which could mean the difference between life and death in a car accident. They make the difference between what type of medication was created. So that's why it's so important to have everything listed just perfectly. Organize and analyze the results. Kyle and Brianna conducted their experiment and organized their results into a graph. When they examined their results, they found the following differences. Number 1. If you add the cream immediately, then the coffee cools more slowly than coffee that has no cream added. Number 2. At the end of the experiment, the cups of coffee with added cream were slightly hotter than the coffee with no cream added. 3. If you add the cream later, then the coffee cools rapidly. And 4. The coffee with cream added later drops to a lower temperature than both the coffee with cream added early and the coffee with no cream. Alright, so no cream here is the black line, and you can see the final temperature is pretty low. If you add the cream at 1 minute, it cools it down a lot at first, but then after a while it just kind of levels off. Cream added at 10 minutes, well when you hit that 10 minutes, then you have a dip and another dip before it levels off. Cream added at 20 minutes, so it's cooling, and then you have your dip and it levels off. From their observation, Kyle and Brianna concluded that the time at which you add the cream does matter. If you want the coffee to stay warmer over a long period, add the cream early. And that's if you're looking over here for your end result. All right. Draw conclusions and communicate findings. Scientists need to communicate their findings and have their peers review their work. Kyle hypothesized that adding the cream early would cause the coffee to cool faster. However, the data refuted this hypothesis. Observations of reality under controlled conditions led Kyle and Brianna, by a process of inductive reasoning, from an erroneous guess to a conclusion that was in keeping with what really happens in the natural world. Kyle and Brianna presented their project at the science fair. In their research, Kyle and Brianna came upon a principle from Isaac Newton called Newton's law of cooling. The law states that a hot object transfers heat to its surrounding at a rate proportional to the difference between the two. So it makes a difference if one's 100 degrees and the other one's 80 degrees versus if one's 100 degrees and the other one is 0 degrees. The scientific method is a process to answer questions and solve problems. The steps of the scientific method include the following. Ask a question or identify the problem first. Second, make a hypothesis. The hypothesis must be in the form of a statement, usually an if-then form, and it must be tested. If is what you do, then what you think the results will be, and because why you think the results will be such. Test the hypothesis by performing experiments or making observations. Identify the independent and dependent variables for the experiment. Independent is what I do. The dependent depends on the independent variable. Fourth, organize and analyze data. Fifth, draw conclusions and compare them with the hypothesis. Sixth, communicate results and compare your finding with those of others. So I just added that last slide to the notes, and I also added under the hypothesis, it is not important if the hypothesis is correct. It is, however, very important that the hypothesis is testable and only test for one variable. And then also under control, I added that it can be the baseline or starting set of data, or you could talk about the controls within the experiment, meaning the stuff that's the same, like you use the same temperature of coffee to start, you use the same kind of plastic cups, you do it at the same time, all that kind of stuff. Can also be, that's more the procedural part of the control. Control can also be your starting data that you're comparing everything else to. All right, that's it for this one.